Okay, guys, I thought we'd do a little bit with helicopters here. We don't have much time to simulate them, or I don't really have a good program for you to use. X-Plane's fine, but you have to have some extra controls. It just isn't the same as flying a fixed wing, which is a lot simpler, especially if you're using the iPad, which I think is, or iPhone, which I think are pretty good options for X-Plane. And all right, so this is a program called DCS, Digital Combat Simulator. They probably have one of the best modeled helicopters for simulators, and we actually use this exact program at Chinook Aviation for helicopter simulator training. So we put people in and get them oriented to muscle memory patterns that involve having to control two sticks, because we're going to be using a collective, as you'll see, and a cyclic, and then the anti-torque pedals. Let's just quickly go over some of the major parts here of this UH-1 Huey. First of all, I think you can see the main rotor is probably the #1 feature, and it is the wing of the helicopter. It's the wing and the power plant and the propeller all in one, and it's going to spin around at very high speed, close to 600 miles an hour at the tips, and it's going to provide us with aerodynamic lift, and depending on how that blade is tilted, left, right, backwards, forwards. So two controls. I'll show you in the cockpit what those look like, but let's just take a look at them now. First control is called collective. So collective is going to change the pitch of the blades, and you can see the pitch of the blades changing, and it's literally changing the angle of attack of the blade, thus providing more lift. So as we want the machine to have more lift or to go in a certain direction at a certain speed, we may need to use collective to increase the lift of the entire blade system. We also have cyclic. So cyclic is like the normal control stick, and what that control stick is going to do, and you can see our counterbalance on the rotor system moving, is it is going to move the entire rotor disc. When it's spinning, it looks like a disc. It's going to move it backwards, forwards, left and right, and that will, push air through the blade system and move the helicopter in whatever direction you'd like it to go. One big problem, though, is when this blade spins under force, it creates torque. And if not for the tail rotor, the helicopter would spin wildly out of control. So the tail rotor on the back, 6 revolutions of the tail rotor for every revolution of the main rotor system. And with anti-torque pedals, a lot of people call them rudder pedals, but there's no rudder back here. With anti-torque pedals, we can increase the lift or power of that anti-torque system. So the more collective we have, the more anti-torque we need to have. All right, let's go in the cockpit and take a look at the controls here. Okay. Oh, here we go. All right, so here's the collective. So when you're flying, one hand is on the collective and the other hand is on the cyclic. The cyclic is going to move us right, left, backwards, forwards. Anti-torque pedals to turn the helicopter or to yaw the helicopter, but also to prevent the helicopter from spinning when we add more collective. As we add more collective, we have to give it left pedal to compensate for that. We have a governor on the collective, and the governor will determine what the RPM of the blade is. The governor, does so automatically, so we usually just turn it up. It's like a motorcycle twist grip, and we let the helicopter's internal systems determine how much power from the engine is going to be given to the blade system. On older helicopters, you had to control this manually, and you had to look at the RPM gauge to make sure that you had sufficient RPMs to maintain the lift that you needed in any given situation. Okay, now this machine is powered by a jet turbine. So let's go ahead and start this up, because the startup sound is always great on these turbine powered helicopters. Go ahead and turn our battery on, and we'll leave our inverter off for now, and our generator is on start. Go ahead and hit our reset for low rotor RPM. So if that rotor spins too slowly, we'll get an alarm. At this point, let's see, we have, I'll go ahead and put collective down and hit the starter. All right, so when we get about 40% RPM, we can go ahead and release the starter. And this is exactly what happens if you're in a machine. If you had a chance to be in a helicopter, there is a lot of vibration. And we'll go ahead and turn our inverter on for our electrics. Bring up to speed here. Want to clear out our master caution. Let's go take a look outside. So if I move the cyclic, you can see how this entire disc is turning. It's all done through what's called a swash plate mechanism. So if we were to go forward, we want some of that airflow going behind us. If we were to stop and fly backwards, we want the airflow moving in front of us, and our left and our right controls as well. All right, let's go back and see if we can do a takeoff here. It's like the old joke is with the helicopters, is like rubbing the top of your head and your stomach at the same time, because you've got to do two things at once. We got to control collective, and we have to deal with our cyclic, and I guess a third thing is our anti-torque. All right, so we're going to go ahead and get a little bit of lift in here, and as the machine starts getting light, we'll go ahead and compensate for that with some left pedal. We'll just go in this hover for a little bit, trying to focus on the outside and the horizon, not looking down. Pretty common. Hovering is a very difficult thing to do. You're going to spend a lot of time if you do helicopter training just hovering and having that real delicate control. Better get back in the cockpit before we have an accident. All right, I'm going to go ahead and put the cyclic forward, and we'll start to move forward. We'll go ahead and pretend we've been given authorization to take off on a taxiway. And as we start to move forward, we're going to get what's called translational lift. So as the air goes through the blades in a forward motion, we're going to start getting lift, because we're going to get more velocity on one side of the rotor system than the other. the total collective result of that will be more lift than we had when we were just hovering. All right, let's see if we can bring this thing around and set it down back on our H on the helipad. Helicopters generally fly much lower than aircraft and much slower. We are doing 80 knots right now. 100 knots. There's our landing spot. We'll go ahead and swing around to the outside and bring it in. So slower than aircraft, one of the big reasons they're slower than aircraft is because as that blade, we'll take a look, go on the outside again here. Well, let's get a nice, that's a cool view. All right. As that blade goes through the air and as we go forward faster, what happens is the tips of the blades start getting close to supersonic. So when that happens, we start coming up with compression and potential shock waves that could stall the entire blade out and cause a helicopter to roll out of control. So that is a limiting factor in the speed of helicopters, is the rotating blade itself in forward motion. All right, so I'm going to use a little pedal here and a little bit of cyclic, just like an aircraft, to turn around. And what we'll start to do is we'll take a look at the magic of the helicopter here, and we will start to slow down. So I'm going to reduce my collective because now I don't want as much lift, and I'm just going to hold the machine with the nose up, and you can see our airspeed start to bleed off. This is for a pilot of a fixed wing aircraft. This gets to be real scary because we don't like to fly slow. Flying slow is the worst thing you can do because you can stall. There's our landing spot over there. We'll go ahead and bring it down as close as we can and see if we can come in vertical here. Normally this is way too much of a vertical descent, because one of the other problems is as a helicopter descends into its own prop wash, it starts losing lift. That's a extremely dangerous situation, and it is called vortex ring state. We just about got ourselves into that as that machine started to have quite a high velocity of descent. And the thing is the more power we add in that state, the worse it gets. So it does just the opposite of what you would think it would do. Normally you're going to add power to get yourself out of trouble. That just exacerbates the situation. So normally we do, somewhat of a kind of like an aircraft approach, because there's runways and you still have to follow all the rules. So we'll bring it in on the runway here, then we'll air taxi it over to our landing spot and call it a day. So I don't want any more than about 1,000 feet per minute on the descent. And as I go ahead and reduce my cyclic, I'm just going to go ahead and maintain that forward motion so I don't have too much in the way of excess descent, and I don't want to descend into my own prop wash. So here, as I'm moving forward, I really don't have that same problem. As I get a little bit slower though, I'm going to start losing some lift. I am going to have to start adding some collective. So there's that slowing down, there's more collective, and we can kind of come up into a hover. We'll do what's called a pedal turn, just with the anti-torque pedals. Let's go ahead and just for fun, we'll just fly sideways a little bit. There's two F-16s landing in Digital Combat Simulator. So, and by the way, DCS is a free program. You get a P-51 Mustang and an Su-25 Frogfoot is the name of the aircraft. So for absolutely free, you get one terrain pack, which is in the Caucasus Mountains, and you get those two aircraft to fly. So you do not have to spend a penny. Of course, they want you to buy more of their modules, like this UH1 Huey. They can be anywhere from $24 to $50. There's F-16s, there's F-18s, there's various other aircraft. And I would say that they are what's called study level aircraft, meaning that the systems are modeled very accurately. All right, we'll just air taxi over to our landing spot here. So again, this is something an aircraft cannot do, is fly above the ground this slow with this sort of control. If you look up at the top left, you'll see a red square, and that will have the position of my cyclic, position of the pedals, and position of the collective. So you can see I have a cyclic input in order to fly slowly like this, and I have some pedal to compensate for the excess torque of the collective. All right, just about ready to set it down and shut her down. And you know, you're constantly making adjustments as you're air taxiing here. We'll actually stay off the dirt. Kind of a thing that drilled into me in terms of even your fixed wing aircraft, is you don't want to have a propeller airplane pushing sand and dust on other aircraft, so you try to be aware of that. Helicopter is 10 times worse. All right, let's just bring her in and just enjoy the ride here as we slowly head down the flight line. Better get back inside and start paying attention, or we drift over into a hangar. It does not take much disturbance on those blades to cause a complete blade failure. So in the Southeast Asia conflict of the 1960s and 70s, the United States flew 33 million sorties in UH-1 Hueys, and 3,200 of them, 3,200 Hueys, were shot down. Those are just the ones that were shot down. I think they produced close to 10, 12,000 of these machines. All right, let's we'll put it in right next to that helicopter there, which is called a UH-60 or Black Hawk, which is kind of the machine that took over for the Huey, but the Huey is still used in private commercial operations. You see a lot of them around here in British Columbia. Everything from logging to heliskiing to surveying. It is a big, powerful machine, and since there's lots of them, there's lots of knowledge on how to repair them, and lots of parts, and lots of people that know how to fly them. It's always a consideration when you're choosing your aircraft. Okay, coming in, and there's our spot. See, we're in about the 19th minute of this video. But you want to see a good landing, right? Get it as close to the H as possible. Straightening out with our anti-torque pedals. And we can go ahead and lower the collective. There we go. Okay. We're home. Go ahead and turn fuel off. So as it winds down here, I'm going to go ahead and move cyclic a bit, so you hope you can see that rotor disc, the entire disc move, backward flight, forward flight, left, right. And there we go. You guys are well briefed on helicopter flying. It's a great aviation field. It's different every day. It is not just getting in and flying the same old aircraft on autopilot. In fact, there's very little automation in helicopters. You're flying the entire time. I hope this was informative, and I hope you enjoyed it. Again, forget helicopters. If you just want to give DCS a try and you have a reasonable computer, you can download it for absolutely free. You get 2 aircraft in one scenery set, basically over in the Caucasus area of, I guess, the former Soviet Union, but Belarus, Georgia, that area. All right, we are done, and happy flying.